Hello, this is Wendy Lightheart. Now that we've learned how to solve systems of linear equations, we will now see how we can use systems of equations to solve application problems. The strategy for using a system of equations to solve problems is to first use variables to represent the unknown quantities. Then we write a system of equations that describe the problem's conditions. And remember that in this course, the systems of equations we've worked with have only two equations with two variables. Once you've written your system, the next step is to solve the system using your method of choice, and then use the solution to answer the problem's question. And our last step, as usual, is to check your answer. It's important to determine whether your answer seems reasonable when checked with the original wording of the problem. Some problems you'll be solving have all the information you need in the wording of the problem itself. However, for some you'll need outside information like a formula, for example. Let's look at a problem that has all the information given in the wording of the problem. This first example reads, 2 burgers and 1 order of fries contain 34 grams of fat, and 2 orders of fries and 1 burger contain 41 grams of fat. Find the number of grams of fat in each item. So remember, our first step is to use variables to represent the unknown quantities. So let's let B equal the number of fat grams in 1 burger, and let F equal the number of fat grams in 1 order of fries. Our second step is to write a system describing the problem's conditions. Looking at the first sentence, we can write our first equation, which will describe the total grams of fat in 2 burgers and 1 order of fries. So here's our equation, and notice this equation states that the number of grams of fat in 2 burgers plus the number of grams of fat in 1 order of fries equals the total of 34 grams of fat. The second sentence will give us our second equation, which states that the number of grams of fat in 1 burger plus the number of grams of fat in 2 orders of fries equals a total of 41 grams of fat. So here is our system. And the next step is to solve the system using our method of choice, and then use that solution to answer the problem's questions. So let's use addition to solve this system and eliminate the f's. We can do this by multiplying the top equation by -2, which will give us -4b minus 2f equals -68. And then we can line up the bottom equation below, and we're ready to add. And this will give us -3b equals -27. And we can divide both sides by -3 to solve for b, to get b equals 9. So now we just need to find f. And if b is 9, then we can substitute 9 in place of b in either of the original equations. If we use this first equation, we get 2 times 9 plus f equals 34. And solving for f, we get f equals 16. Thus, there are 9 grams of fat in a burger and 16 grams of fat in an order of fries. Our last step is to check our answer in the original wording of the problem. Let's see, 2 burgers would have 18 grams of fat plus 1 fry would have 16 grams of fat, and this would give us a total of 34 grams of fat. And 2 fries would have 32 grams of fat plus 1 burger would have 9 grams of fat, which will give us a total of 41 grams of fat. So we got it right. This next problem is a simple interest problem, and it reads, you invested $7,000 in 2 accounts paying 6% and 8% annual interest respectively. If the total interest earned for the year was $520, how much was invested at each rate? So let's draw a diagram to help us organize this information. So we took $7,000 and we split it up into 2 unknown amounts. One of these unknown amounts is invested in an account that earns 6% annual interest, and the other unknown amount is invested in an account that earns 8% annual interest. Our first step is to use variables to represent the unknown quantities. So let's let x represent the amount invested at 6%, and let y represent the amount that is invested at 8%. Our next step is to write a system of equations using these variables. Recall that the total amount invested in the two accounts, or in other words, the sum of x and y, is 7,000. So here's an equation that says just that. The second equation describes the total amount, or in other words, the sum, of interest earned in the two accounts after 1 year. We'll use the formula I, which represents the simple interest earned, equals P, which is the principal, times rate, or R, which is the rate, times T, which is the time in years, to calculate the interest earned from each account, and then we'll add them together. The interest earned at 6% will be the principal, which is x, times the rate of 6%, which is 0.06 in decimal form, times the time, which is 1 year. And this simplifies to 0.06x. The interest earned at 8% will be the principal, which is y, times the rate of 8%, which is 0.08, times the time, which is 1 year. And this simplifies to 0.08y. Recall that the total amount interested earned in these two accounts is $520. So if we add these two expressions, the sum is equal to 520. That is our second equation. So now here is our system. Let's solve this one by substitution. If we solve the first equation by x by subtracting y from both sides to obtain x equals 7,000 minus y, we can substitute this in for x in the second equation, which gives us this new equation in terms of y. So now we need to solve this for y. So we distribute the 0.06, combine like terms, subtract 420 from both sides, and lastly divide by 0.02 to obtain y equals 5,000. Now we need to find x. So we can substitute 5,000 in for y in the first equation to find x. Thus we have x plus 5,000 equals 7,000, and solving for x we get 2,000. Therefore, $2,000 will be invested into the 6% account and $5,000 will be invested in the 8% account. Now let's check our answer in the original wording of the problem. Do both investments add up to $7,000? Well, x plus y is equal to 2,000 plus 5,000, which indeed adds up to $7,000, so this is true. Now, do the two investments yield a combined $520 in interest? Well, the 6% investment yields in interest 0.06 times x, which is 0.06 times 2,000. And this gives us $120 in interest earned. And the 8% investment yields in interest 0.08y, which is 0.08 times 5,000, and this is equal to $400. And $120 plus $400 does indeed add up to $520, so our solution has been verified. For the next two examples, we will simply be setting up our system. We're not really going to solve them. So you can solve them on your own if you'd like. For this example 3, it reads, a jeweler needs to mix an alloy with 16% gold content with an alloy with a 28% gold content to obtain 32 ounces of a new alloy with a 25% gold content. How many ounces of each of the original alloys must be used? Our first step, remember, is to use variables to represent the unknown quantities. So let's let X equal the number of ounces of the 16% alloy to be used in the mixture, and let Y represent the number of ounces of the 28% alloy to be used in the mixture. Now we need to write a system. And for mixture problems such as this one, it is often helpful to use a table to organize our information. In this table, we can keep track of the number of ounces in each alloy, as well as the amount of gold in each alloy. Recall that we let X represent the number of ounces of the 16% alloy, and we let Y represent the number of ounces of the 28% alloy. And in the problem, it tells us that there's 32 ounces of the 25% alloy, which is the mixture. And when it says an alloy has 16% gold content, this means that 16% of that alloy is gold. Thus 16% of X ounces is gold, which we write as 0.16 times X, and 28% of Y ounces is gold, so we write that as 0.28 times Y. And lastly, 25% of 32 ounces of the mixture is gold, so we write that as 0.25 times 32, which can be simplified to 8. Now we're ready to write our system. Since we're mixing X ounces of the 16% alloy with Y ounces of the 28% alloy to obtain our 32 ounces of mixture, we obtain an equation of X plus Y equals 32 from that information. Similarly, the amount of gold content should add up. So the amount of gold in the 16% alloy plus the amount of gold in the 28% alloy will add up to the amount of gold in the 28% alloy. That is 0.16x plus 0.28y equals 8. These are the two equations that make up our system. This next example is a motion problem. It reads, a motorboat traveled 36 miles downstream with the current in 1.5 hours. The return upstream against the current covered the same distance but took 2 hours. Find the boat's rate in still water and the rate of the current. So our first step is to use variables to represent the unknown quantities. So let's let B represent the rate of the boat in still water, and let C represent the rate of the current. We will also use a table to organize the information in this problem. For motion problems such as this one, you will need to use the formula distance equals rate times time. So we will need to determine the distance, rate, and the time for each of these trips, the trip downstream and the trip upstream. Notice that it says the motorboat traveled 36 miles downstream. So we can enter 36 in the table for the distance downstream. Also notice that they covered the same distance going upstream, so we can also enter a 36 in the table for the distance upstream. Now we need to determine the rates. Recall that B represents the rate of the boat in still water. In other words, if the boat was not being affected by the current, the boat would be going B miles per hour. However, as the boat goes downstream, the boat will be pushed faster by the current. In fact, it will be pushed faster by C miles an hour, which is the rate of the current. Thus, the rate of the boat downstream is B plus C miles per hour. When the boat goes upstream, it's going against the current, so it will actually be slowed down by the current by C miles an hour. Thus, the rate of the boat upstream is B minus C miles per hour. And lastly, we need to enter the time for each trip. From the wording of the problem, we see that the time to go downstream took 1.5 hours, and the time to go upstream took 2 hours. So now we're ready to write our equations for that system. So we use the formula to get 36 equals b plus c times 1.5, and we do the same for the second, and there's our system.